All right, guys, here we go. This is the end of the summer camp, but probably a new beginning for you, right? Hopefully, during this short period of time, we transformed how you're thinking about AI, how you think about learning in general, okay, and how you could actually use data to make important decisions in life. All right. So what we're gonna do now is we're gonna go ahead do the presentation. Now the key thing here is I want you to focus on interesting stories. I want you to focus on for example, things that you learned in the camp. Okay. And what we're gonna do now is we need to basically a little bit order, like who's gonna go first, and then who's gonna go next, and who's gonna go for the third. Okay. Um, and Can I have someone volunteer? Who wants to go first? I think Sophia has the best smile. So I felt like maybe, Sophia, your team can go first. Yeah? All right, cool. So let me actually allow participant to share presentations. So I guess, Sophia and, your teammates will go first. Okay? All right, awesome. Take away the stage, please.
Ramona's going to be sharing.
You need to speak a little bit louder. We can't hear you.
Are you guys able to see my thing?
Yes. Yep. Click present. Yep.
Okay, so how many of you have been on a hike? And how many of you have ran into a strange leafy bush and wondered whether or not it will leave you with an itchy rash? Well, we have the product for you.
Whoa, there's a video.
We can show the video in the website, right?
Sorry.
Wow, that's some inspiration video. Look at that. The mountain range looks like that's a pretty big mountain.
We can go with the original video if this one's not working.
Well, here we go. You can share your computer sound. Otherwise, we can't hear you. Here we go.
Although Mother Nature can also be cruel, and many plants are full of wild poisons that give you harsh rashes when you least expect it. The mission of the Poisonous Plants Project is to save the beautiful seeds and plants scattered across the West Coast. We want to help hikers, tourists, and naturalists walking in forests and trails to be aware of the plants and nature that surrounds them. Right at your fingertips, you have the ability to detect a wide variety of dangerous plants. From the volatile foxglove to the convincing oleander, enjoying the outdoors shouldn't have to be a hassle, and the poisonous plant detector will be here when you need it the most.
Oh my goodness, there's even a promotional video. Can we use that video to get more students for AI Camp? Is that okay? Yes? All right. You know what? We're going to get more students. You know what? Once we get more students, I'm going to give you more t-shirts. How about that? Like AI Camp t-shirts. They're pretty good, Although for today, it's probably too hot. Okay.
I'm Sophia. I'm 18 years old, and I helped work on the back end of the project.
I'm Arnold. I'm 16 years old, and I worked on the back end of the website.
Hey, my name's Anand. I'm 16 years old. I work on the front and back end of the website.
Hi, I'm Zhang Kai. I'm 13 years old. I did most of the scripting and authoring of the website.
Hello, I am Ramona. I'm currently 14 years old, and I worked on designing the website.
And I'm Shane. I'm an instructor here at AI Camp, and I had the pleasure to work with this amazing team on the poisonous plant detector.
Awesome. Who actually did the AI part? I mean, all the AI part.
I think it's mostly Anand, Arnold, and Sophia.
Okay. Awesome.
It was a team effort, though, for sure.
Yeah, team effort. Yeah.
So for our project, we decided on a model that could detect poisonous plants. We decided to focus on the most common poisonous plants in California, which are poison oak, daturas, lantanas, foxgloves, silver lupines, stinging nettles, poodle dog bushes, and oleander.
Our objective was to create a program that would help hikers, tourists, and naturalists find out if a plant near them is poisonous or not. And our scope is currently only around the coast of California, and the aforementioned 8 plants that I won't say here. And the steps for creating our project was collecting the images, labeling the images, coding to divide the images into different folders, training our model, and revising where revisions were needed.
Now let's see this product in action.
Wow.
These two images are the images that I just took today, and this one is of an oleander, and let's see if the plant or the product can detect.
So you're uploading that photo right now, right?
Yeah.
Okay.
And wow, I found it with a
Wow.
pretty accurate rounding block and 55%.
Is that near your home?
Yeah,
Is that near your house?
yeah.
Okay.
Okay, now let's start with a different image. This one it's also near my house, and I just took it of a random plant that I'm not sure what the name is, and let's see what it does with this.
Okay, Ramona, you want to speak a little bit louder because we can barely hear you. Okay.
So although I do not know the name of this plant, I certainly know that it's not a poison oak, but this guy was pretty confident that it's poisonous. And that might be explained with the confusion matrix here. And as you can see, it can, its accuracies are pretty high, but it's not 100%, meaning that there is some room for error here. And for anyone else on the team, do you guys have anything to add? So I'll take it. Oh, continue.
I guess the model didn't have a lot of data. Some of the data, though unlikely, could be mislabeled. And yeah, in general, we didn't have a lot to go off of for our 8 plants.
Okay. So let's go through the rest of the website. So this part is where we can test it, and here we included a description of the product and why we made it. Here is a more detailed description of each plant, as well as how exactly they're poisonous and what it does to your body. And this shows our timeline, which is how we made this, and yeah. And then without these resources, we wouldn't have been able to use it. And here are some shameless plugs for them. And here is the video we inserted. And here are some inaccurate bios, which we decided to have our teammates write for us. So yeah, that's not really the best way to get to know us, but yeah. And for anyone who visits the website, they'll know where they can go to make a product like this.
Even though we have a pretty successful product right now, we encountered a lot of challenges on the way. So one of the first challenges we encountered was when we were labeling images. So when we were labeling images, we realized that we have to ourselves know which type of plant is which. So we have to be able to differentiate a stinging nettle from a poison oak or a datura from a lantana. And so that was one hurdle that we faced in the beginning, but eventually we were able to get used to all the different plants. And a second labeling problem that we encountered was, since we had 8 different types of classifications for plants, that means we needed around almost 1,000 images per plant. So that's almost, for us, 6,000, a little bit over 6,000 images we had to create. So that took a lot of time and effort to label all of those images. And then immediately after that, we encountered a second small hurdle. So what had happened was we were training our images, but our coding center decided to delete them or lose them some way. So we had to take some more time and retrain our images afterwards. And the last problem that we had, the last major problem, was our confusion matrix. So as you can see on the right, this is a pretty bad confusion matrix because like there's no definite pattern through the center. A lot of the images are being classified as a no detection stuff and items like that. So what had happened, so we did some troubleshooting, and what we found was the YOLO was only training images with the JPG ending. So we fixed that, and after that, it was detecting all types of files, and then we got the more accurate confusion matrix that you saw in the website demo.
Mm-hmm. Awesome.
For some next steps for our project, one big thing we want to work on was improving the accuracy of our model, because as you saw in the demo, our program sometimes classifies non-poisonous plants as poisonous, and you can also see in the image there that classified a duck as poisonous. So we might want to improve that in the future. Another thing we want to work on was getting our model to detect more poisonous plants and expanding the scope of our project past just the coast of California. We also want to assign different warnings, I guess, to different types of plants, things like do not touch or do not eat based on what type of plant you're looking at, because they can poison you in different ways.
So that brings us to the end of this presentation. Does anyone have any questions?
So the challenges you guys face in the coding center, is it like coding center actually delete your data? Really? What happened?
Yeah, I don't know. We don't know exactly what happened, but we found that all of our trained images were just gone, so we had to retrain them afterwards.
Whoa! Wow. Okay. Okay, that's a new. Yeah. And another question I have for you guys is how did Shane get you to do videos? Because that's pretty remarkable.
It was actually Ramona's idea.
Ah.
Yeah, Shane had nothing to do with it. I mean, Shane encouraged the idea, but it was all them.
Because Ramona designed it, right? Is that right?
Yeah,
And then,
she did all the design.
yeah, and then okay, and then who put that video together?
And Kai did it.
Nice. Wow, that's quite some remarkable things. Maybe we want to, incorporate that, in future kind of students. When they're working on a project, we can do a video. Actually, in the AI.py, there's a little script called YouTube. You can actually upload your stuff to YouTube, and then just say you walk around, to different path in California, whatever. Then you can sort of like using your model to detect poisonous species frame by frame. Right, so it's almost like as you walk around, you see, oh, that's poisonous, that's not. That'd be pretty cool, right? I think overall, this is an awesome project. Do you guys agree? Yeah, can we give them a round of applause? This is awesome. Thank you. Okay, awesome. All right. So who wants to go next? So we got 2 more projects. Actually, before we go there, Shane, do you have anything to say about your group? If you have anything.
Yeah, I was letting them know this before the break, but I was really impressed with like my group. You guys have done an awesome job. You were always like really willing to like learn and like ask questions, which was awesome. And also throughout the project, you were always like ambitious, like whether it be like coming up with a project that had 8 different classes of plants to detect, or like going above and beyond to like make a video, just like you guys were like constantly like trying to find ways to like raise the bar, and your hard work and determination shined through, I think. And you guys did a really awesome job, and it was a pleasure to work with you for the past 3 weeks.
That's awesome. Thank you so much, Shane. Okay, so looks like Oliver's teams want to go next. Looks like, okay.
We can go next. As a heads up, we lost Wanyan and Manasvi to school this afternoon, which is a bummer.
Right.
And then Leo is in and out on Wi-Fi, so he has some slides he's going to try and do, but if he clips out, we're going to have to cover for him.
Yep. Okay. Okay, go ahead and you can share your screen. Yep.
Oh, oops.
Okay. So our group, Soggy Croutons, we created the recycling detector. So what is the recycling detector? Well, the recycling detector is an AI model that can predict what kind of recyclable material a given item is. It can detect up to 5 different classifications: plastic, metal, paper/cardboard, glass, and e-waste. We created our model so that it can help people easily distinguish different types of recyclables, as well as encourage them to recycle more. To further elaborate, because our model has been trained on such a wide range of objects, it is able to classify the majority of common household objects into a recycling category. When people are unsure about which items go into which recycling bin, our model can help them out. Encouraging recycling means that because our model simplifies the recycling process, it makes it so that people are more inclined to recycle in their daily lives.
So now let's look at a demo of the recycling detector. So here's our website. We have our homepage here with the purpose, and it can go up to 5 different classifications. And then we have short testimonials from our team, and there are instructors over there. So we can try this now. For the first image, we have a picture of 2 metal objects and then 1 glass. Oh, actually it was the phone and paper. And then we can do another one. So this is an image of 2 metal cans and then 1 glass, and then we have 1 more to do. This is an image of a cardboard box with a perfume bottle on top of it. It was able to capture the box, but not the plastic bottle.
Mm-hmm.
And if we look at our confusion matrix, we can see that the ones with closer to red, it's more confident on, and these were also the categories that we had more labels for. So plastic, we had the highest amount of labels, and so it's more confident in predicting that category, whereas for paper and cardboard and e-waste, we had the least amount of labels, and so it wasn't as confident. And then if you scroll down, we have our process and then how it works. So back to the presentation, how we made this model. First, we had to collect all of this data. We downloaded some images from the Bing API and also the Chrome extension. We were able to download all of the images that came from one Google image search, and then we cleaned and labeled all of the data using the label box application. We were able to throw away the images that were a little grainy, and we labeled all of them accordingly. Then we trained the data. First, we split it into 3 different groups: train, validate, and test. 70% into train, 15% into validate and test. And then we trained that model, our model, on those training images, and the validation set was used to adjust the weights accordingly to determine which features to give more importance to. And then later we ran the test group and got our confusion matrix to evaluate accuracy, recall, and precision of our results. Later we did the website part of it. We did the design on Nice Page, and we used that template to create the front end, which is where we had a few problems with converting all of the images, adding all of the images, and then also the navigation bar was a little bit of trouble for us, but we got it in the end. And
Oh, you did.
from the back end, yeah, we linked our training model to the web page using Flask app.
Okay, so what's next for our project? In the future, we would like to create it in a larger scale. So we would like it, right now it's for home usage only, but we would like to expand it to be used in recycling centers. And we would also like to determine if it's recyclable. So that means that right now, only our model only expects everything in the picture to be recyclables, but it would be nice if we can first determine if an object is actually recyclable and then detect the different types. And like one of the example image showed, it only detected 1 out of 2 objects in the picture. So our model doesn't always detect everything. So we would like it to detect 2+ objects.
And that is the end of our presentation. Are there any questions?
I have a question regarding if you go back to the confusion matrix. Montessori with sunglasses is so cool though. Okay, so one of the questions I have, if you look at the e-waste, right, that row there, you have more like undetected than, for example, correctly detected, the e-waste. Can you talk a bit like why that's the case?
I think that might be due to, so like when we did plastic, most of our images were plastic bottles or plastic cups. They were all a certain sort of shape, but then when we got to e-waste, it was more like, oh, there are batteries and wires and other electronic devices that have all these different shapes, so it was probably more difficult for the model to detect that.
I see, just because the intra-class variation that really resulted into that. And I think, you know, the rotten eggs team or turkey legs team, you guys also encountered that, right? You know, like, because, you know, like rotten food, you know, could have all sorts of shape and everybody labeled differently, and then that resulted into lower kind of accuracy. Yeah. Oh, one more thing. I think we should normalize this confusion matrix, right? So instead of reading colors, you can actually reading, you know, just the percentages and understand, you know, how well they're doing. Okay. We also have more questions. Do you guys have more questions? Can we give this team also a round of applause? This is a great project as well. You know, we can see that eventually this will be used, you know, whether it's at home, right, in Starbucks, or, you know, even, you know, at a recycling plant, right? We build a prototype in 3 weeks. And if we have, I don't know, like 30 days, guess what we can do, right? We can do a lot of amazing stuff. Oliver, do you want to talk to your team a bit? Any words, any comments?
Oh yeah, I think that was awesome. And I totally agree with the, I think what happened on our e-waste is we each took one type of e-waste. So like one person would take mixers and one person would take cords. Yeah. And then we'd realize that, oh, no one did laptops. And we'd take a photo of a laptop and it'd be like, we have no idea what this is. So I think one of the most important things that we did pretty well, it saved us a lot of time, was good category selection. I think only one of ours was bad. But I think that you just got to think about that more at the beginning of the model.
Yep. Cool. So thank you also, Oliver, for your great instruction. You know, Oliver actually, you know, he's our newest instructor. He doesn't even have a t-shirt, right? I can't t-shirt yet. You know, we're sending him one, but you know, thank you so much, you know, for teaching for us. Okay, cool. Last but not least, we have turkey legs. So for anyone who's watching this video and wondering why we have these weird names, well, that's a long story. But it's basically teams are trying to subcharge one another. But anyway, so which do you guys want to start your presentation? I think this team suffered the most. So let's pay extra attention to them. Okay, it's not easy for them to go through. All right. Okay.
Okay, hello, my name is Shashwat and I worked with Sunny, Achintya, Kush, and Kyra, and our instructor was Richard, and we created the edible food detector. So now let's take a quick overview of our project. Okay, so basically what we did here is we created a model that takes a look at a fruit or a vegetable, and it decides whether it's edible or rotten. For example, in this picture here, the left one, which is the green one, would be edible, and the right one would be rotten, as clear as it shows. So yeah.
So I'll give some examples. So this is our website. It's frozen one sec. Okay. So if we scroll down, this is like why we did it, and then some descriptions of ourselves.
Wait. Hold on. Let's go back a little bit. Let's slow down a little bit. I want to see those photos first. Okay. Oh my goodness.
Yeah, we decided to do baby pictures.
Yeah, those are going from like, you know, like 0-year-old to 3-year-old, something like that.
Yeah.
Is there a criteria for these photos?
I mean, we just decided to do baby pictures.
Okay, so anything you pick.
Yeah. Yeah.
So these are not your teammates picked for you, right?
No, we picked it for ourselves.
Okay. Because I wonder for some of it, you know. But okay, cool. Yeah.
So well, let's try it. One sec, the photos on my desktop. So we'll do blueberries first.
Is that edible?
Yeah, it's supposed to be edible, yeah.
Yeah, it's edible. So we have a little bug where it shows like it labels it multiple times, but it still got edible, right?
Actually, hold on 1 second. So for that bug, I actually talked about it in the lecture. So after all these bounding boxes, right, yellow detected, then we're supposed to do something. What is that something called again? It's called non-max suppression, right? Non-max suppression. I think Sonny was actually speaking about it. Yeah, non-max suppression. But there's a little bug. We need to solve that, but it's not on you, it's on us. Okay. All right.
Yeah. So something we can improve on, or another thing we can improve on, is like certain fruits don't really work very well. So like bananas, they're perfectly fine and edible, but it'll get some rotten because of the brown spots on them.
Yeah, it just depends on whose standard.
Yeah.
Mm-hmm.
And then our confusion matrix is like, it's not bad, but there's definitely room for improvement here.
So we wanted to do this project to help sellers and consumers determine the edibility of their foods, and like have a way for them to decide how fresh what they're buying or selling is. And we also wanted to prevent food poisoning and learn more about AI. So in our second picture, this is an example of a use case, like in a farmer's market. If you take a picture of all the foods you could buy, our project will tell you which ones you should buy and which you should maybe avoid. So our first step in creating this was the ideation phase, or determining the project. We spent the first few days brainstorming ideas and voting on them. Once we had our project selected, we started collecting and cleaning our images. So to do this, we split into two teams. Half of us used a Chrome extension and the other half used a Bing API, and all our images were Google images. And when we had around 1,000 images of rotten and edible food, we started labeling it with an application called Labelbox. And Labelbox allowed us to classify each image as rotten or edible and skip the ones that were blurry or irrelevant.
So before we could train it, we needed to prepare the data. To prepare the data, we needed to bring all the labeled pictures from Labelbox back to the GPU on the coding center so we could split them up into a text file and a JPEG file. The text file held the class, the relative X and the relative Y, so the location of where the box was, and then the relative width and the relative height. Sorry. We then trained the model, which took about 12 hours. And then while that was training, we started working on our confusion matrices. After the model was trained, we needed to evaluate how well the model understood the images and trained itself. So we wrote Python scripts to compare the predicted results and the test results. And that generated us a simple list of the truth, the prediction, and the score. We would then use the list generated above to produce our confusion matrix. To maximize the algorithm in terms of detecting the proper object, we use intersection over union, which causes the algorithm to calculate the amount of area scanned between the true area and the predicted area. This number would range between 0 and 1. After finalizing our machine learning model, we built a web application using NicePage, an application that catalyzes web design. To integrate our model into the website, we needed to set up a backend to connect to our server on the Coding Center GPU. We used Flask to set up this connection seamlessly, and combining Flask for the backend purpose and NicePage for the front end helped us create our website to present our project to you. Moving on to Sunny for our challenges.
So we faced several different challenges when we were working this project. First of all, we had a hard time agreeing on one idea. We had like different ideas, and eventually what we did was we made like a poll, and we chose the one that got the majority of the vote. And our second challenge was that we had different standards of labeling. For example, like some of them labeled the whole fruit, and then some of the team members labeled only the rotten part, and that caused like the confusion in the training part. So we had to relabel some of the images, and then we had to retrain. And we had to look at a lot of spoiled and rotten images while we are labeling. And only with 3 weeks of time, it was a short period of time for us to like learn all the concepts and make our own product out of that.
You know, Sunny, if I were you, I would not, for example, not showing people gross images. I would show them maybe the top 5 ones, you know. But anyway, that's just me. Okay.
Okay, so of course our project was great, but if we had more time, one thing we would have done was collected and labeled more data to improve our accuracy, as shown in the normalized confusion matrix over here. As it shows that rotten 67%, we would like to rise this percentage a little bit if we had more time. And also, we also really wanted to enhance our website by providing more contents. For example, we can link users to websites where we learned all of this Python concepts and all concepts in general that we learned. And finally, the thing we really wanted to do was test this out in real life, in places like farmers market and etc. with the sellers and stuff. So yeah. Thank you.
I have a question for you guys.
Mm-hmm.
So if you go back to those slides where Ashita like presented right here. Where did we use Amazon Web Services?
Sorry, that's my bad.
Actually, we probably use Amazon Web Services because our coding center was hosted in Amazon, but you guys never knew that, right?
No, Richard told us about it so we could understand how it worked.
Oh, yeah. Got it. Okay, that's pretty nice.
So that's like back end.
Yeah. You know, I still feel you guys missed the opportunity of showing us some gross images. You know, we need to share the pain, you know?
I mean, we could, but we have someone on Slack, but I don't know if people would want to really see that.
You know, you shouldn't care about people's feelings. All right, so what I'm going to do is right now we should give them a round of applause. Thank you for looking at the gross images, you know, and making an awesome project out of it, right? That sounds like, you know, pretty good outcome. Richard, do you have a few words you want to say?
Yeah, I think there was a lot of demoralizing points when we found that the models weren't performing the first time, and I think the team really like struggled with trying to make certain decisions because they were just it was kind of those gray areas where I think we don't get a lot of opportunity to practice and making decisions in, but they went with a difficult decision and decided to retrain or relabel all the images again.
Wow.
Which was in the this past week, like a couple days ago, which was a mad sprint. And then basically I said, if you guys can relabel, I'll retrain them for you.
Right.
So a lot of kudos for picking up the energy and trying to see if we can do better. I said that there's no guarantee, but it's like, okay, let's give it a shot. So really proud of them for going with it.
Yeah, yeah. You know, like every day after you guys are gone, you know, we instructors get together, we talk about projects. When Richard, you know, told us about this project, we were like, that's okay, let them fail. It's fine, right? You know, if it doesn't work, you know, that's one of the learning lessons. And, you know, Richard come back next day was like, well, the team kind of refuses to fail. So we have to march forward. And Richard actually definitely spent day and nights for you guys, right? Training all these things, right? Can we all give Richard a round of appreciation? You know, thank you, sir, for pulling your weights, for always be dedicated, for teaching, for organizing, for improving the platform. You know, you're awesome. Okay. Well, right now it's 2:41. We still got a few minutes. Maybe Jin Kai, can you do me a favor?
Sure thing.
Your sister just showed up.
Yeah.
You wrote on your profile, you said, you know, your free time would be, you know, you enjoy very much annoying your sister.
Well, that I think one of my group mates wrote that.
Oh, your group mates wrote that. Okay, I thought you wrote that. But regardless, I was just hoping that you can give your sister maybe, you know, 30 seconds or 1 minute kind of brief of where we are right now. Yeah. Or how did her group do? You know.
So yeah, so I think your group their slideshow was pretty formal and just everything had a lot of formality to it. And I think that they did great, especially because it's basically a two-person team presenting.
Because everyone had a little bit, you know, school to do, okay? Honestly, I think our campus is way cooler than school. You know, if all your teachers are like us, oh my gosh, you guys would be so happy, right? I bet. Okay, enough trash talking from me. I just want to say that, hey, thank you guys for participating. You know, this is actually our second year doing this. Realistically, this is the first year. You know, we had, you know, these great instructors come and help us. You know, like some of you actually also joined from East Coast. You signed up for the last minute, right? I don't know how, you know, why you trusted us, but you did. You look at the website, you trusted us, and we're doing this. Hopefully you're now regretting your decisions. And I know so many of you also, you know, from the start, you know, like when I first see, you know, Jin Kai and Wang Yang, you guys sign up and it was like, you know, coming from one family, I was like, wow, that's a lot of money. That's a lot of trust, you know? So we're like, you know, so thrilled, you know, to have you guys here. And guess what? This is also end of the summer, even though today is a perfect day for summer, but it is the end of the summer. And, you know, sort of like concludes, you know, one of the journeys for AI Camp. And frankly, I know some of you never really liked, for example, this online kind of format. And certainly we all wish, you know, one day we're going to see each other face to face, you know, having barbecue, right? As I said, AI Camp, thank you, barbecue. You gotta come, right? You gotta come. When we can do this, you gotta come, okay? But of course, if you have, you know, abnormal temperatures and don't show up, you know, we won't miss you. But, you know, but if you're normal, we'd love to see you. And I hope what you can do is, you know, really take these lessons we're trying to teach you and ingrain it with your daily lives, right? Whether it's, you know, how you learn stuff, or, you know, when you look at a difficult subject from this point on, you should be like, I did AI before, I'm not scared of this shit, right? I'll be able to actually learn all these things, I'll be able to conquer it, right? I'll be able to, you know, go through it. And also, you know, so sort of things you learn about how to talk to people, how to use data to make decisions, right? Those are things I hope you can take it and run with it, right? And probably, you know, a few years later, you can tell us whether this is going to be something, you know, interesting, useful, meaningful or not, okay? And one more time, that is, once you're AI Camp students, you're always AI Camp students. We are trying to build a community, right? So the Slack is always open to you, right? You can always find us, right? You know, and I hope, you know, during the next couple of years, we're gonna, you know, grow more. More students will realize, you know, what an AI Camp is. We're actually gonna, you know, right after this, we're gonna work on another class, which is coding for AI, right? Which is essentially, try to, what we observe is people who know about coding, they come to AI camp, they work, they learn more, right? So we're trying to level the field and actually giving people a little bit more, I guess, easier kind of ramp, right? Learning about AI, right? And certainly we would need your help a little bit later. Maybe it's like, for example, like there's some of the presentations you guys made, they're awesome. Some of you, could also help us, maybe, giving us a testimony of what AI camp is. We have ambitions to actually grow AI camp at a global level. I think we're the lucky ones. We can learn it first, but we constantly get applications from, for example, kids in Indonesia, India, right, South Africa, even UK, Japan, but they don't have the chance, right now we don't have the capacity to teach them. And what we hope to do, certainly, right, is be able to, put our classes for free for them and they can learn it, right? And your contribution, like how we actually are using you as a guinea pigs, you just didn't realize that, right? And we're using you to improve our classes. Certainly we have big ambitions, and I'm so excited for your future, for AI Camp's future. And one more thing is thank you instructors, Shane, Oliver, and Richard, for your dedication, for how much, you have, helped us improve this program. Thank you so much. Okay. So thank you guys. Thank you. Okay. All right. So with that, I'm just going to close the camp, right? And as I said, you're welcome to stay in AI Camp, Slack. Maybe we're gonna have an alumni, gathering day again. We're gonna do some silly things, play some games, right? That's definitely in the future. And we're gonna continue to invite you for, events gonna happen in our camp, right? So for example, guest speakers, things like that. Okay. Any other questions or anything you want to say? Okay, well, then I will see you guys when I see you. Bye-bye.
Thank you.
Bye-bye.
Thank you.
Thank you.
Sure. Bye-bye.
Thanks, Michael.
Yep, no problem. Bye-bye. Bye for now.